Okay, let's unpack this. We're talking about moving data, right?
Yeah.
Taking your most valuable stuff, your data assets,
Hmm.
from being locked down locally, maybe in a dusty server room somewhere,
Yeah, the classic setup.
and letting them, well, live and thrive in the cloud. It's this dynamic, scalable world.
It really is. And it's pretty much the defining move for, modern business agility.
Absolutely critical,
Yeah.
but also incredibly complex
Yeah.
and potentially pretty catastrophic if you mess it up.
Exactly. This deep dive, it's all about the data migration playbook. We're moving way beyond just like copying files.
Right.
We're looking at the whole strategic overhaul needed, moving that critical business data between platforms. Often it's from older legacy systems or on-prem stuff into a managed cloud environment. We've been looking at sources covering everything from, the basics, the foundational stuff like ETL and virtualization,
The building blocks.
all the way to the really high stakes, real world challenges. Think migrating giants like Oracle BI or Salesforce. That's serious business.
Okay, so our mission today, for you listening, is to give you that shortcut, help you get really well informed on this.
Yeah.
We're going to map out the actual processes, the strategies you need, the famous 6 Rs we hear about, and even look at some surprising performance impacts. What actually happens when you successfully bend that data from one place to another?
It's definitely more than just moving files.
It really is. It's like moving the company's operational brain, isn't it?
That's a great way to put it. So whenever we talk about moving data in a structured way, the conversation, it almost always starts with ETL. Extract, transform, load.
The classic.
It's the foundation, really, for seamless data integration, migration, visualization. But here's the thing, the crucial distinction. The ETL you use for a massive, maybe a one-off cloud migration, it's often way more complicated than the, let's say, conventional ETL you'd use for just building a regular data warehouse.
Okay, why? Why is it more complicated in a migration context?
Because fundamentally, you're dealing with operational data, live data.
Ah, okay. So not just old historical records you're archiving.
Exactly. You're moving the actively beating heart of the business, the transactional stuff. And you have to do it while keeping the lights on, basically.
Right. You can't just shut everything down for a week.
Not usually, no. So let's break down the phases, starting with E, extraction.
Getting the data out.
Right. Retrieving data from its original source. Now, the complexity here isn't always the retrieval itself, though that can be tricky. It's identifying and accurately capturing data from all the sources.
All of them.
All of them. In a big company, that data could be spread across, I don't know, decades-old databases, weird legacy apps, maybe even different cloud storage units you're trying to consolidate.
Yeah.
If you don't capture everything accurately from the start,
You've got gaps. Big one.
immediately, critical data gaps in your shiny new cloud environment, it undermines the whole project from day one.
I kind of picture it like emptying out a huge old attic. You think you know where everything is.
Yeah.
But you always find some forgotten box tucked away, full of priceless photos or critical documents you didn't know were there.
That's a perfect analogy. That's exactly it. Miss that box and the whole move, the migration, it's already flawed.
Okay, so you've hopefully found all the boxes.
Yeah.
What's next? T.
Now we move to T for transformation. And honestly, this is where the bulk of the time and frankly, the budget usually gets eaten up.
Right.
Because the data you extracted, it's almost never in the right format for the new target system, especially a modern cloud one.
So transformation is the conversion phase, getting it ready for the new house.
Exactly. If extraction is grabbing all the boxes from the attic,
Yeah.
transformation is opening every single one, checking every item, deciding what's junk, cleaning things up, maybe relabeling.
Standardizing everything, making sure it fits the new shelving units.
Precisely. It includes some really crucial steps. First, and maybe most importantly, cleansing.
Data cleansing.
The glamorous part. Yeah, right. Removing inconsistencies, fixing errors, dealing with duplicates. Some sources suggest, up to 60%, 60 of a migration project's effort and budget can go just into this T phase.
60%. Wow.
Largely because legacy data accumulated over decades is often messy, to put it mildly.
So ignoring cleansing just means you migrate the junk faster.
Pretty much. You're just moving the problems.
Right.
Second, during transformation, you apply business rules.
Okay, like what?
That could mean aggregating certain data points, maybe performing complex calculations needed for the new system, or optimizing the data structure itself, like sorting or indexing specifically for the new, maybe hyper-efficient analytics engine you plan to use in the cloud.
Got it. The end goal here is standardization then, making everything uniform and reliable.
Exactly. You're trying to minimize those errors that creep in with manual handling over the years.
Yeah.
Enhance reliability and accuracy. Because if you try to shove, say, unstructured text notes or wildly inconsistent date formats into a very strict cloud database schema...
Your reports are going to break. Or just be wrong.
Exactly. Your queries will fail, your analytics will be off. You absolutely have to ensure every field meets the required schema of that target system before you even think about loading it.
Which brings us to L, loading.
And finally, L for loading. The transformed clean data gets loaded into the destination system. Sounds simple, maybe the easiest step.
Doesn't sound too bad.
But it requires really careful management because often the systems are live or need to be live again very quickly. You have to coordinate that transition meticulously to prevent critical system downtime.
And data loss, obviously.
And data loss, absolutely. A well-executed ETL process, especially the load part, ensures the data isn't just there, but it's consistently accurate, fully integrated, ready to use. Often this isn't one big drop either. It might be iterative, incremental loads to manage risk.
Okay, so ETL is like the big organized moving truck. Takes time, effort, careful packing.
Good analogy, yeah.
What about data virtualization? I hear about that too. Is that like beaming the furniture over instantly?
Maybe not beaming, but it's definitely a different approach. It offers more flexibility, potentially more scalability, especially for accessing real-time data across different platforms. And the key thing is, it does this without needing constant physical data replication cycles like ETL demands.
Okay, no moving truck needed then. How does it work?
Well, the mechanism is pretty fascinating. Instead of physically moving and consolidating all the data into one massive central place, like a data warehouse, data virtualization basically aggregates data from all those different physical sources, could be old on-prem servers, could be a dozen different SaaS apps you use, into a single unified virtual data layer. It's like a smart abstraction layer.
So the data doesn't actually move?
Not physically, no. Yeah. When an analyst or an application queries this virtual layer, the system is smart enough to go out, fetch the necessary bits of data from their original sources, maybe do some processing or joining on the fly, and then deliver the combined answer, all pretty much in real time.
Wow. Okay. That sounds incredible for a business that needs to be agile, react quickly.
It absolutely is.
But what are the trade-offs? There must be some, right? If I can just query live data whenever I want, why would anyone ever bother with the huge cost and effort of ETL?
And that's the core strategic question, isn't it? The benefits are really clear. You get real-time analytics immediately available for decisions.
No waiting for the nightly batch job.
Exactly. So you get reduced latency. Teams can access and analyze data super quickly, avoiding those delays. This really enables that rapid iteration, pivoting strategies if the market shifts.
Makes sense.
And often it can mean cost-effective infrastructure because you avoid the massive storage costs and the processing power needed to build and maintain huge, redundant copies of all your data.
Okay, sounds great, but I'm still stuck on the performance. If the actual data is still sitting on some slow, maybe overloaded on-prem server somewhere, doesn't querying it through this virtual layer just add more delay? Isn't it slower?
That is the potential drawback. That's the trade-off. The virtualization layer hides the complexity, which is great, but it does add its own layer of abstraction and processing overhead. Right.
So if your underlying source systems are already struggling, maybe poor network bandwidth, slow disk I/O, then yes, that real-time query through the virtual layer might actually perform worse than a query run against a pre-optimized, physically loaded data warehouse built with ETL.
Okay, so it's not magic.
Not magic, no. Yeah. Virtualization tends to be most effective when those underlying sources are already reasonably performant, and your main goal is that quick access, that integration agility, rather than, say, raw speed for massive, complex data crunching or joins.
Got it. So the source material we looked at, it sort of frames virtualization as more of an enhancement, maybe, rather than a total replacement for ETL.
Correct. It's often positioned as something that optimizes the data flow, improves system integration. It can serve as a really powerful foundation for things like real-time dashboards, predictive modeling, maybe AI-driven decision support systems.
Because the data is always current.
Yeah.
Exactly. It ensures the underlying data for those advanced functions is current and accessible the moment it's generated. It provides that unified view you need for sophisticated models without necessarily replicating everything constantly.
Okay, let's ground this in the real world a bit. One of the most common and often high-stakes scenarios companies face is moving data, or maybe just integrating data, between systems like Oracle BI Business Intelligence and Salesforce.
Oh, yeah, that's a classic pairing and a classic headache.
They're both pillars in many enterprises, right? But they do fundamentally different things, don't they? Their whole purpose, their data structures, they kind of clash.
They absolutely do. You've basically got the analytical side of the house versus the transactional side. Oracle BI historically is all about deep historical analysis, complex financial reporting, aggregating lots of data for insights.
Looking backwards, often.
Often, yeah. Whereas Salesforce is the operational CRM. It's handling the day-to-day, customer interactions, sales pipelines, marketing campaigns, logging activities as they happen.
So the challenge isn't just like copying tables from A to B. It's making these two completely different philosophies about data actually talk to each other effectively. What happens when you try and merge or migrate between them?
The complexity is just enormous. It really resides in a couple of key areas.
Yeah.
First, data mapping. This is huge.
Defining what means what.
Exactly. An account ID in Salesforce might conceptually link to a customer number or maybe even a general ledger ID in an Oracle financial module that feeds BI. But the underlying formats, the rules, the schemas, they won't match up cleanly. You end up having to create really detailed, often custom transformation rules just to bridge that gap.
I can imagine.
Second is data consistency. This is critical. If a salesperson updates a customer's address in Salesforce right now, an analytical report run moments later in Oracle BI ideally should reflect that change. But ensuring that happens without causing massive database locking issues or synchronization delays or inconsistencies, that's really, really hard.
And what about all the messy stuff in Salesforce, like the free text notes fields, eno captures, activity logs, trying to port that into the highly structured relational world of Oracle BI must be a nightmare.
It absolutely is. You can't just dump unstructured text blobs into a field expecting numerical analysis in BI. It just doesn't work.
Right.
So organizations have to plan really carefully data extraction strategies, schema conversion, transformation logic, and crucially, minimizing downtime during the process. If your migration effort causes Salesforce to stop recording sales leads, even for an hour.
Ouch.
Or if Oracle BI loses its reporting capability during quarter end, the business impact, the financial disruption can be massive, ensuring those two systems can interact reliably or that data can move between them consistently. It's maybe one of the ultimate tests of a migration team's planning and execution skills.
Yeah.
Hashtag 2.2. Core drivers and high-level challenges of cloud migration.
Okay, so we've established it's hard, really hard. Why are so many organizations putting themselves through this? What's the big push for this massive investment and, let's face it, upheaval?
Well, it really boils down to a mix of economic necessity and the pursuit of competitive advantage. The cloud just offers things that are incredibly difficult or expensive to replicate on-premise.
Like raw power.
Raw computational force, absolutely. But also highly adaptable IT resources. Think about the ability to instantly scale your compute power or your storage up or down based on real-time market demand or business needs.
The elasticity.
Exactly, elasticity, that kind of flexibility. The rigidity of most legacy on-premises data centers just can't match it. They were built for peak load, which means they're often underutilized and expensive most of the time.
And the financial model.
Yeah.
That's got to be appealing to the folks holding the purse strings, right?
Yeah.
Shifting from CapEx to OpEx.
Oh, it's hugely appealing. Moving away from capital expenditure, buying massive servers, storage arrays, networking gear, and then depreciating it over years. Towards operational expenditure, basically paying only for the cloud services you actually consume, like a utility bill. That frees up enormous amounts of capital that can be invested elsewhere in the business. It's a massive incentive for the C-suite.
Makes sense. What else is driving it? Beyond the money and flexibility.
There's also a significant reduction potentially in operational risk. The major cloud providers offer levels of security, resilience, automated backup features.
Things most companies can't afford to do themselves.
Often, yeah. They operate on highly proven, massively redundant architectures. Replicating that level of resilience and security internally is often just too costly or complex for individual organizations. So moving to the cloud can actually increase your overall business agility and operational efficiency by offloading some of that infrastructure burden and risk.
Okay, but let's pivot to the flip side, the roadblocks. We looked at some survey data highlighting the biggest pain points people actually encounter when they do this.
Yeah.
What tends to rise to the top? What are the big migration killers, statistically speaking?
Yeah, that data is pretty revealing. The leading challenge, cited by a pretty hefty chunk, 35% of respondents, is data compatibility.
Still. after all this time.
Still, it refers to those fundamental issues like, mismatched data formats between the old system and the new cloud service, different database schemas, sometimes even obscure proprietary data types that exist in the legacy source but have no direct equivalent in the target cloud environment.
So even with good ETL tools, you still hit these walls.
You do. It often requires significant manual transformation work, custom scripting, things that automation can't always handle perfectly. It's a systemic issue.
Okay, data compatibility is number one. What's the number two reason migrations go sideways?
Number 2 is downtime. Unplanned downtime specifically, reported by about 25% of respondents.
And that hits the bottom line directly.
Instantly and hard. We've all heard anecdotes or maybe even experienced it. Major retail sites down during peak season, financial services firms unable to process transactions. The cost can run into millions of dollars per hour during unexpected outages caused by, say, a failed migration cutover attempt.
Wow.
So that careful planning, minimizing service interruptions, especially for those really critical business functions, absolutely vital.
And rounding out the top three hurdles.
That would be data integrity, cited by about 20%. This is the risk that during the transfer process itself, data gets lost or corrupted.
So it moves, but it's wrong.
Exactly. Maybe you successfully copied all the tables, but did you lose a few rows somewhere? Did some parallel process introduce inconsistencies between related data? This is why rigorous validation and reconciliation checks after the move are so incredibly important. You have to prove the data arrived intact and correct.
Okay, so compatibility, downtime, integrity, those are the big three.
Yep.
But there are other major challenges lurking too, right? Especially around sensitive information.
Oh, absolutely. Security and privacy concerns are constant, and they should be, especially when you're dealing with personally identifiable information, PII, financial data, health records, anything regulated.
GDPR, HEPA, all that fun stuff.
All that. It demands meticulous attention to encryption, both in transit and at rest, maybe tokenization, and ensuring stringent compliance checks are met. Not just in the final destination cloud environment, but during the entire transfer process itself. Data needs to be secure at every step.
Any other common gotchas?
Yeah, a couple more systemic ones come up. One is the risk of vendor lock-in. You migrate to a specific cloud provider, start using their proprietary databases or services, and suddenly find it's incredibly difficult or expensive to move off that platform later if you need to.
Right, portability becomes an issue.
Exactly. And the other one, which is often overlooked until it's too late, is performance degradation after the migration. You move the application, but if the new cloud environment isn't correctly sized, or if the database isn't properly tuned for the new infrastructure.
It runs slower than it did before.
It can, yeah, which is obviously not the result anyone was hoping for. Post-migration optimization is key.
Okay, so faced with all those drivers and all those challenges, this is where the high-level strategy comes in. You can't just, blindly throw your data and apps over the fence to the cloud. You need a plan. And that's where these 6 R's come into play, right?
Exactly. They provide a framework, 6 specific strategic approaches to cloud migration. And the one you choose really dictates the approach, the likely timeline, the cost involved, and ultimately the kind of operational efficiency you're likely to achieve.
It's a trade-off, basically. Balancing speed and risk against how much modernization you actually accomplish.
Precisely. And the context for choosing your R is always based on a couple of factors. What kind of cloud service model are you targeting? Are you going for infrastructure as a service, IaaS platform as a service, MIS, or maybe software as a service, SOXs?
Okay.
And second, how much modification are you willing or needing to make to your existing applications?
All right, let's start with the first R, rehost. Also known, maybe more commonly, as lift and shift. This sounds like the simplest route.
It generally is. Rehosting means you take your existing application environment. Let's say you have a big Oracle database running on a specific Linux version inside a VMware virtual machine.
Yep, standard setup.
You basically lift that exact configuration, the whole VM image essentially, and shift it straight into the cloud. You run it on a virtual machine service there, like AWS EC2 or an Azure VM. You're targeting an IaaS model.
So minimal changes to the actual application or its dependencies.
Minimal to none. That's why it's popular. It's usually the fastest way to migrate.
Quick win?
Can be. It's the most straightforward approach, can often be highly automated using various tools, and it's generally considered lower risk because you're not messing with the application's code logic.
Right, less chance of breaking something functional.
Exactly. For organizations maybe just dipping their toes into the cloud or perhaps facing a really urgent deadline like needing to exit a costly data center lease very quickly, R1, lift and shift, is often the necessary first step. It gets you out of the old environment and into the cloud infrastructure quickly, avoiding operational silos.
But there's always a but, isn't there? The immediate cost savings or the speed might be a bit deceptive in the long run. It feels like you're just taking your old way of doing things, maybe your legacy technical debt, and just plopping it directly into a potentially expensive premium cloud environment.
That is the critical drawback.
Yeah.
That's exactly right. While it's fast, you fundamentally fail to leverage many of the benefits that make the cloud attractive in the first place, those cost-effective, efficient cloud-native services.
Because the app wasn't designed for them.
Precisely. It was designed for your old data center, so you might run into unexpected performance bottlenecks, the scaling might be inefficient, and your operational costs in the cloud could actually end up being higher than you anticipated, certainly higher than if you used more modern cloud architectures.
So you're paying premium cloud prices, but running a legacy setup.
Pretty much. It's really an infrastructure move getting you onto cloud hardware. It's not true digital transformation of the application itself.
Okay, so if R1 is just moving the furniture as is, what's R2? Re-platform. The description here is lift, reshape, and shift. Sounds like an intermediate step.
It is. Replatforming means you're still moving the core application to the cloud, but you're making some minor but key optimizations or modifications along the way, specifically to take advantage of some managed cloud services, usually in the PaaS or maybe optimized IaaS space.
Okay, give me an example.
Think of it as shifting your application code but upgrading the foundation it runs on. A really common example is moving an on-premises database server, maybe MySQL or PostgreSQL.
Right.
And instead of running it on a generic cloud VM, like in R1, you reconfigure your application slightly to use a managed database service from the cloud provider, like AWS, RDS Relational Database Service, or Azure SQL Database, or Google Cloud SQL.
So you're still using MySQL, maybe, but you're not managing the actual server OS, the patching, the backups yourself anymore.
Exactly. The cloud provider handles all that heavy lifting. You just connect to the database endpoint. Or another example, taking your existing Java application code and deploying it directly onto a platform as a service offering, like Google App Engine or AWS Elastic Beanstalk, instead of managing the underlying servers.
Okay, so the application logic itself doesn't change much, but the infrastructure dependency and that day-to-day maintenance headache are drastically reduced.
That's the goal. The pros are pretty significant. You generally get better efficiency than R1. You leverage the cloud provider's expertise for things like security patching and high availability, and you significantly cut down on your team's operational overhead. Less time spent managing infrastructure.
So like a good middle ground. What are the downsides?
Well, it definitely demands more planning than a simple lift and shift. You have to investigate compatibility, potentially make code changes to use the managed service APIs, reconfigure dependencies. So it increases the complexity, the time, and the initial cost compared to just rehosting.
So a bit more upfront investment, but hopefully better ROI than R1 over time.
Generally, yes. Much better ROI over the medium term because your operational costs should be lower and you're starting to actually leverage cloud benefits.
All right, R3. Repurchase. This sounds radical. We're not just moving or tweaking the old stuff. We're ditching it entirely.
Essentially, yes. Repurchase means switching to a completely different platform or product altogether. Most often, this involves moving from a legacy on-premise application to a modern software as a service, or SaaS solution.
Dropping the old thing and buying something new off the shelf.
Pretty much. Think about replacing an aging, maybe cumbersome, on-premise CRM system with Salesforce, or moving from an old financial package to NetSuite. Or, in the data world, maybe abandoning a traditional self-managed data warehouse and ETL toolset and moving to a cloud-native database as a service, or data solution like Snowflake or Google BigQuery or Databricks.
Okay, the benefits seem obvious here. You get immediate SaaS advantages, right?
Yeah.
No installation, no servers to manage, no maintenance headaches. The provider handles all that.
Exactly. You get access to the latest features, often pay-as-you-go pricing. And it's a clear way to replace genuinely outdated legacy platforms that might be holding the business back. From a strategic viewpoint, pitching a move to a modern SaaS platform can be a really strong argument when you're asking for long-term digital transformation funding.
Sure, looks good on the roadmap.
Right.
But there's got to be a significant human cost here, right?
Right.
And maybe a financial one up front. You're not just migrating data, you're changing fundamental business processes probably. And people hate change.
You've hit the nail on the head. While the technical maintenance might disappear, you have other challenges. First, you have to purchase the new platform license or subscription, which can be a significant upfront or ongoing expense.
Right.
Second, and often more disruptive, is the required technical and organizational shift. Your staff, your users, they have to learn a completely new system.
Training resistant.
Exactly. Teams that had maybe spent years mastering the old legacy system now need to acquire completely new skill sets for this SaaS platform. That means training costs, a potentially steep learning curve, and yeah, almost guaranteed resistance from some users who were comfortable with the old way, even if it was inefficient.
So you're kind of trading infrastructure and maintenance costs for potentially high subscription fees and significant change management effort.
That's a very good summary of the trade-off, yes.
Okay, moving up the complexity scale. R4, re-architect, also called refactoring sometimes. This sounds like the most involved option, completely redesigning the application.
It is. This is the ultimate level of cloud transformation. Re-architecting means you're fundamentally rethinking and redesigning the application and its entire solution architecture specifically to be cloud native. You're not just moving it, you're rebuilding it for the cloud environment.
What does that look like in practice?
The classic example is taking a big old monolithic application, one giant code base where everything is tightly coupled.
Yeah, the hairball.
Exactly. And breaking it down into smaller, independent, loosely coupled microservices, maybe running them in containers like Docker and Kubernetes, or using serverless functions like AWS Lambda or Google Cloud Functions.
So really embracing modern software design patterns specifically for the cloud.
Precisely. And this is where you can potentially achieve the highest levels of efficiency and agility. You get the maximum cloud-native benefits, incredible scalability, high resilience because services are independent, potentially zero infrastructure maintenance if you go serverless, and the ability to deploy changes to individual components on demand quickly, often without any downtime for the whole system.
That sounds like the dream scenario for DevOps and agility. The gold standard.
It really is. For long-term digital transformation, you're building for the future.
Right. I sense another but coming, because you're essentially doing major software development here.
Right.
Ripping out the old core, changing fundamental designs. This has to be the most demanding strategy by far.
Absolutely. It demands the most time, the most resources, requires really deep domain expertise in both the application and cloud-native architectures, and consequently, it's almost always the costliest approach up front.
You need serious skills on the team.
You need high levels of DevOps maturity, dedicated and often expensive cloud architects and engineers. You really need to pull off an R4 migration successfully. The strategic assessment has to be rigorous. Does the expected long-term benefit, the agility, the scalability, the potential cost savings down the road truly justify the significant multi-year investment and risk involved in a full re-architecture?
Right. If you're only planning to keep the system for another couple of years anyway, R4 probably doesn't make sense.
Probably not. The ROI calculation is critical for R4. You need that long-term vision.
Okay, we've covered the 4 main ways to move things, but there are 2 more R's. Retain and retire. These sound more like deciding not to move something.
Exactly. They're the common sense options, really. Retain simply acknowledges the reality that sometimes certain applications are just not ready, or maybe not suitable for the cloud right now, or maybe ever.
Like what kind of systems?
Could be specific, very old legacy mainframe environments that are stable and still doing their job. Could be systems with extremely complex hardware dependencies, or maybe performance bottlenecks that would be too risky or expensive to untangle and move to the cloud.
So you make a conscious decision to leave them on-premise, at least for now.
Yes, after a careful assessment. It's not ignoring them. It's making a strategic choice to retain them where they are.
Okay. And the last R, retire.
Retire is just what it sounds like, decommissioning applications or systems that are simply no longer needed or used by the business.
Taking them out back and shutting them down.
Pretty much. This is actually a really vital cleanup step before or during a major migration initiative. Identify the stuff nobody uses anymore, the redundant systems, and get rid of them.
Why is that so important in a migration context?
Because it reduces complexity. It saves resources. You're not spending time and money migrating something useless, and it streamlines the future cloud environment you're building. There's absolutely no point migrating applications or data that provide no business value. Declutter first.
Never migrate what you don't need. Makes perfect sense.
Okay, so let's say you've chosen your R strategy. Now we get down to the nitty-gritty, actually moving the data bits from point A to point B, the physical or virtual transfer. And the choice here often hinges on two main things. How much data do you have, and what's your network connection like?
Right, so first up, offline transfer. This sounds old school, like shipping hard drives.
It often involves exactly that. Offline methods are primarily used when you don't have access to high-speed, reliable network connections between your source location and the cloud. Or sometimes, even if you do have a connection, the sheer volume of data is so massive, we're talking many terabytes or even petabytes, that transferring it over the network would take weeks or months, or the network egress charges from your current location would be prohibitively expensive.
So you resort to physical media.
Correct. It relies on using physical, portable storage devices. For, let's say, smaller workloads, maybe 10 terabytes or less, the sources suggest a customer-owned device, like a bunch of high-capacity external hard drives, might actually suffice. You copy the data, encrypt it, and ship it yourself.
Okay, but for the really big stuff, petabytes.
For workloads ranging from tens of terabytes up to the petabyte scale, you typically turn to specialized provider-owned devices, services like AWS Snowball, Azure Databox, or Google Transfer Appliance.
Ah, the ruggedized briefcases full of storage.
Exactly. But using them is a significant logistical challenge. Don't underestimate it. You have to order these physical units from the cloud provider. They get shipped to your data center. You have to integrate them into your network, manage the high-speed data transfer onto the devices, making sure it's encrypted properly.
And ship them back.
Then arrange secure shipping back to the cloud provider, and then the provider handles the secure ingestion of that data into your cloud storage account.
Wow, that involves physical security, maybe customs if you're crossing borders, tracking shipments, the whole physical supply chain operation on top of the data management.
It really is. It requires careful planning and coordination. So the alternative, and often the preferred method, if feasible, is online transfer.
Using the network.
Using the network, yes. This typically involves leveraging dedicated migration services offered by the cloud providers themselves. Things like AWS Database Migration Service, usually called DMS, or the Azure Database Migration Service, or Google Cloud's Database Migration Service.
Okay, what makes these services better, assuming you have the bandwidth, especially for migrating databases or systems that need to stay online?
The key advantage is that they enable continuous data synchronization, often allowing for real-time or near real-time data migration with minimal or even near zero downtime during the cutover phase.
How do they manage that?
They typically work in two phases. First, they perform an initial full load, copying the baseline snapshot of your source database to the target cloud database.
Okay, get the bulk over.
Right. But then, crucially, they switch into a continuous replication mode using something called change data capture, or CDC.
CDC.
Change data capture. It monitors the source database for any ongoing changes, new rows being inserted, updates, deletes, and replicates those changes over to the target database almost immediately.
Ah, so the target stays in sync with the source live.
Exactly. The source and target systems remain perpetually in sync, or very close to it, right up until the moment you decide to do the final cutover and point your applications to the new cloud database. This drastically minimizes that window of disruption for the business. Hashtag tag 4.2, migration cutover strategies, managing risk.
Okay, that continuous sync sounds crucial for minimizing downtime. But eventually you still have to make the switch, right? You have to actually cut over, point everything to the new system, that moment of truth.
Absolutely, the cutover. And how you manage the inherent risk involved in that moment is paramount. The strategy you choose here often reflects the organization's tolerance for potential downtime or disruption.
So what are the main approaches? I've heard of the Big Bang. Sounds dramatic.
It can be. The Big Bang cutover strategy involves moving all the users, applications, and data dependencies over to the new cloud system all at once, usually within a single, tightly scheduled maintenance window.
Get it all done in one go.
That's the idea. The main advantage is it offers the fastest overall transition time. You rip the Band-Aid off quickly.
But the risk?
The risk is the highest. If anything goes wrong during that single cutover operation, a script fails, a configuration is missed, a dependency wasn't accounted for, you risk a catastrophic failure. You could end up stuck in the middle with neither the old nor the new system fully operational, and the business grinds to a halt. It requires absolutely flawless planning and testing.
Okay, so Big Bang is fast but risky. What's a more cautious approach?
That would be a phased or incremental migration. Here, you don't move everything at once. Instead, you migrate the system in manageable sequential chunks or segments.
Like move one department's users first, or one part of the database.
Exactly. Maybe you migrate users by region or applications by business function or data by subject area. This is inherently a lower risk approach because if something goes wrong with one phase, it only impacts a smaller subset of users or data.
Makes sense, especially for really huge systems.
It's particularly well suited for migrating very large multi-terabyte data warehouses or maybe complex monolithic applications that can be logically broken down. The downside: the complexity increases dramatically.
How so?
Because for an extended period, you have both the old and the new environments running simultaneously. Data might exist in both places. You have to manage complex data reconciliation processes, ensure consistency, maybe build temporary interfaces between the old and new systems. It requires much more coordination over a longer time frame.
Okay, lower risk, but more complex management. Is there an even lower risk option for situations where absolutely nothing can go wrong?
Yes, for the truly risk-averse or in highly regulated industries, there's the parallel run strategy.
Running both in parallel.
For an extended period, yes. You set up the new cloud system, get it running, but you keep the old legacy system fully operational as well. Then, for a defined validation period, maybe weeks or even months, you run both systems concurrently.
So transactions hit both systems.
Ideally, yes. Or you have ways to feed data to both and constantly compare the outputs, the results, the performance. This is definitively the lowest risk strategy because if the new system encounters any issues, throws errors, or produces inconsistent results.
The old one is still chugging along, processing business as usual.
Exactly. The business isn't impacted. You have a fallback. This approach is often mandated in sectors like banking or healthcare systems, where any data loss or service disruption is completely unacceptable due to regulations or safety concerns.
But the cost and complexity must be huge.
Off the charts. It's by far the most complex and expensive strategy to implement and maintain. You're essentially paying for duplicate infrastructure, duplicate operations, and you need sophisticated tooling and processes for that constant comparison and reconciliation between the two environments. It's heavy duty. Hashtag tag 4.3. Dealing with database diversity. Homogeneous versus heterogeneous.
Okay, another layer of complexity when we're talking databases specifically, it really matters whether the source and target databases are the same type, doesn't it?
Oh, massively. This is a critical factor. We talk about homogeneous migration versus heterogeneous migration.
Homogeneous sounds easier.
It generally is. Homogeneous means the source and target database engines are the same, or at least highly compatible. Think migrating from an on-premise MySQL database to a cloud-managed MySQL service like AWS RDS for MySQL or Google Cloud SQL for MySQL.
So same engine, different location.
Right. The underlying data structures, data types, SQL syntax, they're largely identical, so the migration process is much more straightforward. Often, you can use native database backup restore tools or replication features.
Okay, that's the easy path. What about the other one? Heterogeneous.
Now you're entering a different world of complexity. Heterogeneous migration is when the source and target database engines are different.
Like moving from Oracle to PostgreSQL. Or maybe Microsoft SQL Server to Amazon Aurora's MySQL compatible version.
Exactly, those kinds of scenarios, and the complexity just explodes because now not only is the infrastructure different, but the fundamental way the databases work is different. The application code written for Oracle won't just run on PostgreSQL.
Data types don't match up.
Data types differ, the SQL dialect has variations, internal structures like indexing or partitioning work differently. And crucially, complex database objects like stored procedures, triggers, custom functions. They're usually written in engine-specific languages, like PL SQL for Oracle versus PLPG SQL for PostgreSQL.
Yeah.
They won't work on the target.
So you can't just copy the data and expect it to work. You have to translate everything.
You have to perform schema conversion. It's mandatory. You're essentially translating the entire internal language and structure of the database from the source dialect to the target dialect.
How on earth do you do that reliably for a huge, complex database?
You absolutely need specialized tools. Again, using the AWS ecosystem as a common example, you typically rely on a combination of their database migration service, DMS, which handles the actual data movement, and CDC.
Right.
But Critically, you use it in conjunction with the AWS Schema Conversion Tool, or SCT.
SCT, what does that do?
The SCT is crucial because it automates a large part of that heavy lifting involved in translation. It analyzes your source database schema, the tables, data types, views, and even tries to convert stored procedures and functions and generates the equivalent schema for the target database engine.
It does the translation automatically.
It automates a significant percentage, yes, especially for standard data types, basic table structures, simple SQL routines. It saves a massive amount of manual effort. However, and this is important, the sources we looked at consistently confirm that for really complex elements.
Like very intricate stored procedures.
Wow.
Or custom functions using obscure features.
Exactly. Or maybe really complex business logic embedded in triggers. For those parts, SCT might only manage a partial conversion, or it might flag them as needing manual review and rewrite. So some level of manual intervention and expertise in both the source and target database engines is almost always still required for complex, heterogeneous migrations. The tool gets you maybe 80–90% of the way there, but that last 10–20% can be very tricky.
Okay, that makes sense. Can you walk us through a crucial technical detail in how DMS actually handles the data movement in these heterogeneous scenarios? Something about constraints?
Yes, that's a key operational technique, especially during the initial full load phase when you're copying the bulk data in parallel. For performance and to avoid potential deadlocks, it's often recommended, and sometimes necessary, to temporarily drop foreign key constraints on the target database tables before you start that parallel bulk data copy using DMS.
Drop the constraints. Doesn't that risk data integrity?
Temporarily, yes, it removes that check. But here's why. Imagine you're loading millions of rows into two related tables, say orders and order items, simultaneously. If the foreign key constraint linking order items back to orders is active on the target, the database has to constantly check for the existence of the parent order row every time an order item row tries to load. With many parallel loading processes running, this can lead to contention, locking, potential deadlocks, and it dramatically slows down the overall data copy process.
Okay, so dropping them lets the parallel loads run much faster without blocking each other.
Exactly. The bulk data copies much faster without those checks happening constantly during the load. Then, after the entire data set for those related tables has been confirmed as transferred and is present on the target,
You put the constraints back.
you then safely recreate those foreign key constraints. At this point, the database can efficiently validate the relationships because all the data is already there. Relational integrity is restored before you proceed further or cut over. It's a standard, albeit slightly scary-sounding, optimization technique for large-scale database migrations. Hashtag tag 4.4, real-world performance impact. AWS to GCP case study.
Okay, this is interesting. We have a specific data point here, a case study that kind of challenges the narrative that migration is just about escaping old hardware or maybe saving costs. It suggests you can actually get significant performance gains.
Yeah, this one was quite surprising. It involved migrating a sample database application, specifically a MySQL database hosted on AWS, over to Google Cloud Platform's Managed MySQL service, Cloud SQL. So a homogeneous migration in terms of the engine, MySQL to MySQL, but heterogeneous in terms of the cloud provider infrastructure.
Right, and the results were pretty compelling.
They were quite compelling and maybe a bit counterintuitive if you assume cloud providers are all the same. After moving the workload and performing standard post-migration optimization and configuration tuning on the GCP side,
What happened?
they saw tangible performance improvements. Throughput, measured in transactions per second, TPS that the database could handle, actually increased by a significant 25%. It jumped from around 500 TPS on the AWS setup to 600 TPS on the GCP setup for the same workload.
Wow, a 25% increase in capacity just by changing the underlying cloud platform and tuning. That's huge.
It is. And it wasn't just raw throughput. The user experience likely improved too, because average latency for client requests hitting the database was reduced by 20%.
Faster response times.
Exactly. It shrank from about 100 milliseconds on average down to 80 milliseconds on GCP. The analysis attributed this primarily to factors like improved underlying network infrastructure within GCP for that specific region and workload, and perhaps more efficient internal load balancing or instance types used.
Interesting. Was there any difference in how hard the server was working, like CPU usage?
Yeah, that was another key finding. The GCP Cloud SQL instance actually showed lower overall resource utilization, both CPU and memory usage, while handling that higher throughput and lower latency. This suggests potentially better resource allocation or optimization within the GCP infrastructure for that specific MySQL workload profile.
Okay, so the big takeaway here isn't just cloud is better than on-prem. It's that the specific cloud provider and how well their infrastructure is optimized for your particular workload can make a real measurable difference in performance.
Exactly. Migration isn't just about escaping the old. It can be an active opportunity to leverage potentially superior optimization offered by a different modern cloud provider.
There has to be a caveat, right? It's not guaranteed you'll see this.
Absolutely, a major caveat. That success story is highly contingent on two critical factors. First, the chosen destination provider, in this case GCP, happened to have superior optimization for that specific application's workload profile. A different application, maybe one heavily reliant on different database features or I/O patterns, might have shown the opposite result. It might have performed better on AWS. It's workload dependent.
Okay, no silver bullet.
No. And second, and this is crucial, those gains weren't achieved just by flipping a switch. They relied on rigorous post-migration tuning efforts. The engineers still had to go in after the move, analyze performance, optimize database indexes, tune specific slow queries, adjust connection pool settings, and generally fine-tune the configuration for the new GCP environment.
So the platform provides the potential, but you still need the expertise to unlock it.
Precisely. The platform provides the raw materials and potential, but the skilled engineers deliver the actual performance through careful optimization after the migration is complete. You can't just lift and shift and expect magic performance gains without that follow-up work. Okay, so pulling this all together, if you want your migration to be successful, delivering on performance, minimizing those risks we talked about, organizations really need to embrace and institutionalize a set of best practices. It's mostly about rigorous planning and validation.
Right, and that starts way before you even think about moving the first byte of data, doesn't it? With a pre-migration assessment.
Absolutely non-negotiable first step. This involves doing a thorough inventory of all your database assets. What do you actually have? Where is it? Then, doing detailed performance profiling. You need to measure how things perform now. Exactly. What's the typical query response time? What's the peak throughput? What are the normal concurrency levels under your current load? And critically, meticulously mapping out all the system dependencies. Which applications talk to which databases? What other systems rely on this data?
You absolutely have to know exactly what you've got, how it performs, and what it connects to before you even start planning the move. Otherwise, you're flying blind.
Totally blind. Next up, leveraging automation wherever possible.
Makes sense. Doing things manually is slow and error-prone.
Hugely. Automated tools are crucial for both speed and efficiency, and reducing human error. Our sources highlighted some compelling stats here. Something like 75% of surveyed organizations found that using automated migration tools was effective. And the impact can be significant. For example, one source suggested automation could reduce the average downtime needed for a complex data transfer from around 12 hours down to just 3 hours.
Wow, that's a 9-hour saving in potential business disruption. That's massive.
It really is. Especially for critical systems, automation pays off.
Okay, assessment, automation.
Yeah.
What about testing? You can't just hope for the best on cutover day?
Absolutely not. Rigorous testing and validation is key. You need a dress rehearsal.
Wow.
Or several.
Like a pilot migration.
Exactly. Conducting a test run, maybe transferring just a representative subset of the data, is mandatory. This validates everything end to end before the main event. Does the network connectivity work reliably? Are all the security permissions and credentials correct? Can the source system actually handle the read performance required for the extraction?
And it lets you find problems early.
Precisely. It proactively identifies bottlenecks, errors, or things you missed in planning. It lets you make necessary course corrections before you attempt the high stakes, full migration with all the production data. If the test run fails or reveals major issues, you don't proceed with the full migration until those are fixed and retested.
Common sense, but probably often skipped under pressure.
Unfortunately, yes. Finally, a specific point about unstructured data, especially moving files around. Preserving the details is crucial. Yes, that's metadata preservation. This often gets overlooked but can be critical. When you're migrating unstructured file data, think documents, images, logs from, say, a traditional file server to cloud object storage like Amazon S3 or Azure Blob Storage. You absolutely need to ensure that critical file system metadata is preserved during the transfer. Services like AWS DataSync or Azure Databox are designed to help with this. We're talking specifically about things like POMISX metadata,
PUSX metadata,
like file ownership information, user and group, permissions, read, write, execute bits, timestamps, creation, modification, access times. If this metadata gets lost or changed during the move to object storage, things break badly. File system permissions get messed up. Applications that rely on those specific ownerships or timestamps might suddenly fail because they can no longer correctly read or write the files in their new cloud location. It can cause immediate operational failure for any file-dependent applications you migrate. So preserving metadata is essential for those kinds of workloads. Hashtag 55.2, emerging trends and future directions.
Okay, looking ahead now. The world of data and cloud, it never stands still, does it? What are some of the key emerging trends that are likely to shape how these migration projects are done in the near future?
Yeah, things are definitely evolving. One of the biggest trends we're seeing is the much deeper integration of artificial intelligence and machine learning, AML, into the migration process itself.
AI helping with migrations.
Yeah. Well, future trends point towards AML being used not just for analyzing the data after it's migrated, but actually for optimizing the migration process itself. Think AI tools that can help automatically identify data quality issues during the transformation phase, or maybe predict potential bottlenecks in the transfer, or even model the most resource-efficient migration paths and timings based on past projects.
Smarter planning and execution using AI.
Exactly. And also enhancing predictive analytics capabilities immediately post-migration by understanding the newly structured data faster.
Interesting. What else? Are people still just picking one cloud and sticking with it?
Less and less so, it seems. We're definitely seeing a strategic move towards hybrid and multi-cloud architectures becoming the norm rather than the exception.
So using multiple cloud providers, plus maybe keeping some stuff on-premise.
Precisely. Organizations are intentionally choosing to distribute their data and applications across various cloud platforms like AWS, Azure, GCP, and potentially their own remaining on-premises systems. There are a few drivers for this.
Like avoiding lock-in.
That's a big one. Using multiple clouds gives you leverage and reduces the risk of being locked into a single vendor's ecosystem and pricing. It also ensures redundancy and resilience. And perhaps most strategically, it allows organizations to optimize performance and cost by choosing the best cloud provider for each specific workload.
Right. Maybe use one cloud that's strong in data warehousing and another that excels at machine learning services.
Exactly that kind of specialization. Pick the best tool for the job.
And the infrastructure itself. It feels like it's becoming more abstracted, less about managing servers.
Definitely. Serverless databases and serverless computing in general are a massive trend impacting migrations and new application development.
We mentioned serverless functions earlier with R4. How does it apply to databases?
Serverless database models, like Aurora Serverless or Azure SQL Database Serverless, essentially reduce the operational overhead even further. They automatically scale the compute power and sometimes the storage based entirely on the application's real-time demand.
So you don't have to provision for peak load anymore.
Pretty much. The user or developer often doesn't even worry about provisioning specific instance sizes or managing idle capacity. You just consume what you need when you need it, and the platform handles the scaling behind the scenes. This dramatically simplifies the infrastructure layer and can be incredibly cost-efficient, especially for applications with variable or unpredictable workloads.
Makes sense. Okay, one last thing. Are there external forces, like laws or regulations, starting to influence migration decisions?
Yes, absolutely. There's growing legislative pressure, particularly aimed at reducing vendor lock-in and promoting data portability. A prime example is the European Union's Data Act.
The Data Act, what does that do?
It's landmark legislation set to become fully applicable around September 2025. One of its major aims is to try and abolish many of the current vendor lock-in practices used by cloud providers. Crucially, it includes provisions stipulating that cloud service providers must significantly reduce and eventually phase out entirely excessive fees charged for outbound data transfer, basically, the cost of moving your data out of their cloud.
Ah, the egress fees. Those can be huge.
They can be a massive barrier to migrating between clouds or back on-premise. The Data Act mandates these fees should be phased out by January 2027.
Wow. If that happens, it could make switching cloud providers much easier and cheaper.
Exactly.
Yeah.
It could significantly simplify the cost calculation and remove a major barrier to future platform portability. It might make strategies like repurchase R3 or even replatforming between clouds much more economically viable and strategically attractive down the line. It's definitely something to watch. #outro. So, okay, after diving through all of that,
Yeah.
what does it all really mean for you listening?
I think the key takeaway is that successful data migration, it's really not just about speed or simply copying files. It's fundamentally about a structured transformation.
Yeah.
It's about cleaning, preparing, optimizing that data for its new home in the cloud while meticulously managing and minimizing the operational risk during the move. We've kind of navigated the whole journey, haven't we? From the basics, the ETL pipeline, all the way through those advanced cloud strategies like the 6Rs. And I think it proves that with thorough planning, the right framework, and the right tools, you can turn those daunting terabytes of legacy data into genuinely agile, valuable, high-performing assets in the cloud.
Absolutely. It's achievable, but it requires discipline.
So maybe the ultimate strategic decision for listeners today is to really consider that trade-off. Are you prepared to make the big investment, take the bigger risk upfront, for the ultimate agility you get from re-architecting your system for the cloud that R4 approach?
The long-term play.
Or does your situation demand the reduced risk and the faster timelines you get from a simpler lift and shift R1, even if it means leg optimization initially?
That choice you make today, it really does fundamentally shape your organization's flexibility, its costs, and its competitive edge for probably the next decade. It's a critical decision point. Planning, assessment, and that rigorous validation we talked about, they are absolutely everything, especially when you're moving the crown jewels, the critical data of the business.
Definitely. You absolutely don't want your big data migration project to fail. So maybe the final thought, or a witty punchline for today. Remember, if you don't clean your data before you load it into that shiny new cloud platform, you're not really achieving digital transformation.
No. What are you achieving?
You're just getting a much faster, probably more expensive way to prove your existing data was wrong all along.